All right, this screencast is for 4.3c particle motion revisited. On Monday, we discovered that a particle will speed up if the acceleration and the velocity outputs have the same sign. Either they're both negative or they're both positive. And also that a particle slows down if the acceleration and velocity outputs have different signs. So what we're going to do first, we're going to do all of these things here. Number one, we're going to identify all of the start and stop positions for the given time interval. Describe the direction of motion of the particle. So when it moves left on what interval, when it moves right on what interval, etc. And then give all the time intervals for where the particle speeds up or slows down. Okay, so here is our position function right here. All right, so first, what I should find, because it's asking for start and stop positions. So it does ask for my start position. All right, so and if this is my position function, in order to find my initial position, all I have to do is plug in my time equal to 0. So if I plug in x of 0, I can see this is going to be 0, 0, 0, and I get negative 5. I don't see in my notes units of feet. So it must be in feet in your note packet. All right, so feet, negative 5 feet. So next, in order to find the stop positions, I need to find when the velocity is equal to 0. So since this function here, the x of t, here this is my position function, my velocity is the derivative to the position function. So I have to find my derivative. So x, put it down here, x prime of t is equal to 6t squared minus 28t plus 22. I can tell my initial velocity if I plug in a 0 here, 0 here, then I know my initial velocity is going to be 22 feet per second. All right, so in order to find when the particle stops, I need to set my derivative function equal to 0 and solve for t. All right, I see that I have an even term everywhere, so I'm going to factor out a 2. So that's 3t squared minus 14t plus 11. And continue to factor here. So 0, let's see, 3t, 1t, and then a negative 11 and a negative 1. Okay, so I see that it'll stop when, for the values of t that would make this factor here a 0, and the value of t that would make this factor here a 0. So the t values where it stops is going to be 11/3 and 1. All right, now I'm going to make a sign chart eventually. Actually, I can go ahead and do that. So let's just go ahead and write our sign chart. So I'll put it over here on the side. All right, so this is my sign chart for my first derivative or my velocity function, so I'll label it accordingly. All right, 11/3 is bigger than 1, so I'm going to put 1 here, and I'll put 11/3 over here. All right, so what you would then do, I like to use the factored form here. If I plug in, let's say if I plug in a 0, and here I need to determine my signs, and I'd get a negative and a negative, so this would be positive. The number I could plug in here would be 2. If I plug in a 2 in here, I'd get a negative times a positive, so that's going to be negative. And if I plug in, let's say, a 4 in here, I get a positive, positive, so this would be positive. All right, now wherever on this interval here, or the sign chart, wherever you see this plus, and I'm starting at 0 time. Wherever there's a plus, that means my particle is moving right. Wherever it's negative, my particle is moving left. And positive, again, it's moving right. Okay, the next video I'll go ahead and talk about the acceleration, and then I'll close it out with direction and speeding up and slowing down.